Welcome to the European Southern Observatory. In this video, we will introduce how to prepare MATISSE observations. MATISSE, the multi-aperture mid-infrared spectroscopic experiment, is a second-generation mid-infrared instrument for the Very Large Telescope Interferometer that operates simultaneously in three atmospheric windows, the L, M, and N bands, from 3 to 13 microns. It combines the light from either the 4 unit telescopes, or UTs, or the 4 auxiliary telescopes, or ATs. MATISSE simultaneously measures 6 square visibilities and 4 closure phase values. The squared visibilities measure the spatial extent of a target along the projected baseline, while the closure phase is a robust quantity, largely independent of atmospheric perturbations, used to investigate asymmetry or detect high-contrast companions in the source geometry. MATISSE provides different spectral resolutions: low of 30, medium of 500, high of 1000, and very high of 3300 in the L and M bands, and low of 30 and high of 220 in the N band. The chosen spectral resolution and detector integration times, or DITs, which determine the detector readout window size, allow to cover different wavelength ranges. For the L and M bands, spectral windows of 0.08 micrometer in high resolution and 0.16 micrometer in medium resolution are accessible, which the user can center following the information reported in the template manual. The hybrid mode is the standard MATISSE observing configuration. In this mode, the L and M bands operate in SciPhot, simultaneous photometry, utilizing beam splitters to acquire photometric calibration simultaneously with fringe observation. Instead, the N band operates in high-sense, high-sensitivity mode, where beam splitters are removed to maximize flux in the interferometric channel. Therefore, while L and M photometry is simultaneous, the N band requires mandatory subsequent photometry exposures. These are performed using telescope chopping, which allow to measure the stellar flux and subtract the thermal background, a step which is crucial for computing visibilities in the N band and properly calibrating M band data. MATISSE can be used in two main configurations. First, MATISSE standalone, the classical observing mode where MATISSE performs its own fringe coherencing and uses the infrared imager sensor, or IRIS, for focal laboratory guiding to provide image stabilization. But second, the gravity for MATISSE, or graph format mode. This mode can be used when the correlated K magnitude of the target is bright enough that fringes can be tracked with gravity. With graph format, MATISSE observations are carried out with the fringes stabilized by the gravity fringe tracker. This allows to use longer DITs, which improve the signal-to-noise ratio in the lower spectral resolution modes, or alternatively, extends the limiting magnitudes to slightly fainter targets, and makes L and M full-band observations possible. With graph format, dispersion-induced fringe jumps occur more frequently than with the MATISSE standalone, causing a loss of signal and a reduction of the signal-to-noise ratio. Fringe jumps can be limited by observing in low precipitable water vapor, or PWV, atmospheric conditions, and the current recommendation is to request PWV smaller than 5 already in phase 1. A specialized graph format mode is the narrow field of axis mode, which offers the capability to track fringes with gravity, while MATISSE points to a nearby offset position to record fringes. This is useful for observing planets or brown dwarf companions to stars that can be tracked by gravity. Once your MATISSE proposal is accepted, you can move to the ESO Phase 2 tool for preparing your observing material. In the Phase 2, you can define your observing blocks, or OBs, which specify the details of your observations. If you are not familiar with the Phase 2 tool, we have a dedicated video about it in this channel, see link in the description. You can use the MATISSE Exposure Time Calculator, or ETC, for visibility calculations and their feasibility. Each OB shall include a target acquisition template and, typically, one science template. The acquisition template contains the information to point the telescope at a source and set up the VLTI and instrument for observation. When observing with MATISSE standalone, the target is acquired by MATISSE and a fringe search is done during the acquisition template. When using graph format, The gravity fringe tracker searches, finds, and tracks the fringes for MATISSE. This is done using the single field of axis mode of gravity. MATISSE then takes the control back and performs the target acquisition, similarly as with MATISSE standalone, to refine co-alignment and co-phase the instruments. Finally, MATISSE offset its internal delay lines to match gravity's optical path differences. The two MATISSE science observation templates, for MATISSE standalone and for graph format, share many common parameters, such as integration time, central wavelength, number of exposure cycles, and spectral resolution, necessary for configuring the instrument's optical path and detectors. At phase 2, you should also select the master band for coherencing, which is used to perform fringe coherencing during fringe exposures. In most cases, the L band should be chosen as the master band, because the L band typically offers higher sensitivity for fringe detection compared to the N band. When operating with graph format, this option should be kept to L. To perform a photometry sequence using chopping, the template parameter doPhotometrySequence should be set to true. When observing with graph format, chopping is offered depending on the K-band magnitude of the target as advertised on the instrument webpage. The graph format science template also offers the possibility to define the relative offset in RA and DEC to support observations with the narrow field of axis mode. Please note that the chopping sequence is currently not supported in this mode. You should also prepare OBs for appropriate calibrator stars. MATISSE is offered with two observing sequences, either calibrator science or science calibrator, or calibrator science calibrator. Calibrator stars for N band and L band can be found, for instance, with the ESO tool Calvin, or the SearchCal tool provided by the GMMC, or through the mid-infrared stellar diameters and fluxes compilation catalog provided by the MATISSE consortium. Finding a star that is suitable for both bands at the same time can be tricky. You should make sure already at phase 1, this is for proposal submission, that suitable calibrators are available. In case no good L and N calibrators, so-called hybrid calibrators, are available, you should consider using a calibrator science calibrator sequence with one calibrator for L band and one for N band. This is even more important in case of imaging programs aiming at producing images in both L and N band. Science-only observations, when no absolute calibration of the visibilities is required or possible, are also offered. Before finalizing your phase 2, please ensure you meet all the general and instrument-specific requirements. This includes providing finding charts, integration times and offsets, setting the correct Coude guide stars and baseline configurations. Once your OBs are reviewed and approved by your assigned support astronomer, your observations will be scheduled for observation at Paranal Observatory. Once the data is taken, raw data is placed in the ESO Archive and it is immediately available to the users, although they become public only after the corresponding proprietary time. Thank you for watching. More information can be found in the MATISSE user manual and associated online documentation. For any questions, please contact us at ESO User Support. Happy observing!